Okay, let's look at the homework 6.3, 6.4, problem number 11. Alright, so let's evaluate this improper integral. Alright, first thing we would do is I'm going to use a substitution. I'm going to let u be 2x minus 7. Right, then go through the usual drills. Take the derivative of u with respect to x, and which gives you just 2. And then take the reciprocal of both sides to get the dx over du is equal to 1/2. Right, then we can just multiply both sides by du to isolate dx. So dx is going to be du over 2. Alright, then we have to convert the lower limit and the upper limit. So x goes from 5 to infinity. The corresponding u values are, so if you plug in 5 here, 2 times 5, 10 minus 7 is 3. And 2 times infinity minus 7 is still infinity. So it actually goes from 3 to infinity. So this can be rewritten as integral from 3 to infinity, and then you have a 1 over square root of u, right? Dx is du over 2. Right, so let's clean this up a little bit. So this can be written as, right, so 1/2 is just constant. So I'm gonna kick this constant out, right? So I'm gonna put 1/2 in front. Then you have an integral from 3 to infinity. Right, then I don't like fraction or a square root, so I'm gonna write it as a u to the, right, u is sitting on the bottom, so it's a negative power. Then square root, so it's going to be 1/2 power. Right, then you have a du. Right, so since this is an improper integral, we're going to use a limit, so it's a 1/2. Then you have a limit as t approaches infinity. Right, integral from 3 to t. Then you have u to the negative 1/2 power with respect to u. Right? Right, you still have 1/2. And limit, we need to take care of that. As t approaches infinity. Right? Antiderivative of u to the negative 1/2 would be add 1 to the power, so it's going to be positive 1/2. Divide by 1/2 is same thing as multiply by 2. Right, then going from 3 to t. Right, luckily we have 1/2 in front and there's 2, so we can cancel those. Whoops. We can cancel 2 on top. Let's see. 2 on top and 2 on the bottom. Alright, then we have, let's see, we have limit as t approaches infinity. Right, then plug in t, so it's going to be t to the 1/2 power minus 3 to the 1/2 power. right? But as t approaches infinity, we know that this guy right here is going to approach infinity, right? So this is going to be infinity, right? Which means that this improper integral is divergent or diverges. Alright, so let's type it in. Alright, so we know that the distinct integral diverges, and I guess we have to type in diverges. Alright, let's check the answer. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.